So is my screen visible?
Yes, sir.
Okay, thank you. So in the last class, if you see, we are discussing about purpose of storage of water in the buildings, and as well as the different factors on which the storage capacity of buildings depend upon. Now with this, we'll move forward and we'll talk about some other aspect of storage capacity and different structure which facilitate storage in the building. Now there are some codal provision associated with the storage capacities, and in India we have IS 2065 1963, and according to that we have a classing storage capacities which is required for different type of buildings for different purposes. So we have a classification of buildings and associated storage capacities which is required. So we can go through this table to have a better idea about the classing storage capacity which is required, at least for tenements having common conveniences. So we need a 900 liters net storage capacity for water closet seat, and accordingly if the number is increased, we have to multiply with the 900 liters. Now for residential premises, where we don't think of tenements having common conveniences, 270 liter per water closet seat and 180 liter for each additional water closet seat in the same flat is what is calculated, and accordingly if you have like n number of flats, you can multiply with n. Next is the for factories and workshops. So industrial building is what we are going to talk about here. So in this case, again 900 liter per water closet seat and 180 liter for urinal seat. And when we talk about public places like cinemas, public assembly halls, etc., again we have 90 liters per water closet seat. Since in all this case which we discussed in the in row 1 and in row 3 and 4, in all these cases we have that public gathering, and because of that, per water closet seat, the total amount of storage which is required is much more compared to the residential area. And 350 liters per urinal seat, since the chance of utilizing water closet is lesser in frequency compared to the urinal. That is the reason in this case of cinemas and public assembly halls we have 350 liters for urinal seat. Moreover, from the similar code only this particular table also has been taken, and here you can see that depending upon different type of floor and as well as the storage what is required. So for premises occupied tenements with common conveniences, in such case ground floor and first, second, third and fourth and upper floors, the storage is required 500 liter per tenement. And the remark is here that providing no downtake fitting installed. So if you don't talk about any other storage, only you talk about the storage per tenement, in that case for ground floor and first, second, third, fourth and upper floors, we need 500 liter at least per tenement. Now for premises occupied as flats or block, so in those cases where we have flat societies, so we have to, from for the ground floor we need nil. We don't need any extra storage, because directly you are going to get that. Similarly, like what we discussed in the previous case, so for ground floor it is nil, but for the first floor, second floor, third floor, fourth floor and upper floors, we need 8,000 liters per tenement in this case, because here we are talking about a full flat where we don't have common conveniences. So that is why the storage which is required is increased from 500 to 8,000. In this case also, that the remark is provided no downtake fitting are installed. So in this case also we are not talking about any other accessories apart from the main storage. Fine. So with this I'll slowly move towards the next structures which I was talking about before. So basically elevated storage reservoir or overhead storage tank, which we say. So this is the most common overhead storage facility, which we can see in the right hand side. I have just given a schematic diagram. So basically this particular type of overhead storage facility consists of several components such as manhole, ventilator, water level indicator, overflow pipes, and then we have outlet pipes, we have wash uh, pipe, we have, apart from washout pipe, we have the inlet pipe also. So this is what is actually known as overhead tank or ESR, elevated storage reservoir. Fine. So when water is to be distributed at a very high pressure, elevated tanks are constructed with steel or RCC. So RCC elevated tanks are very popular, and mostly we can see in the vicinity of our society. If we are living close to any town or cities or municipalities, then we can see such kind of elevated storage tanks in huge numbers in India. And so these are actually preferred in RCC because there are some inherent advantages, like it has long life and very less maintenance is required, and a decent appearance as well. So that is the reason RCC is considered to be the major material for construction of elevated tanks in our country. Now, but in recent days, we have this, pre-stressed RCC. You know very well that the same concept has come in case of all those piers and flyovers, bridges. So we don't directly use RCC. So instead, we use pre-stressed RCC. And similarly, in case of tanks, also we can use pre-stressed RCC material, and they are even more economical than plain RCC tanks. All the overhead tanks are provided with inlet, outlet, drain pipe, overflow pipe, water level indicator, manhole, ladder, ventilators, and lightning conductor, etc. As I mentioned before, and about 60 to 100 centimeter wide balcony is provided around the tank for inspection and the maintenance of the tank. So this particular structure is also seen pretty well. If you see uh, tanks, overhead tanks, you can check it, like there will be a balcony of 60 to 100 centimeter wide, and you get a very good view if it is accessible. And in few of the places, people utilize them to get that as well. And these tanks can store large quantity of water. They are usually actually planned based on the design population. So usually they are huge, and accordingly the structural stability is provided, and the design associated with that structural stability is also provided during the construction. Fine. So now the another one type of storage which we are going to talk about here is underground storage reservoir. So like what we have over here, overhead tank, we have underground reservoir as well. In many places, you can see that these reservoirs are used for mostly storing and distributing clear water, and these reservoirs are connected on high natural grounds and are usually made of stones, bricks, plain or reinforced concrete. So these are the primary material. Now the side walls are designed to take up the pressure of the water when the reservoir is full, and you need to think of this particular point very well, that when it is empty, the earth pressure will give apply pressure in the other direction once it is full. So let us try to understand this fact from this particular figure. So in this case, if you see, so once water is full, so this water which is there within, this will actually give some pressure to this side wall, and this will basically counter the pressure coming from the soil in the vicinity. However, when the tank is empty, then there is no water within the tank, and in that situation, there will be pressure which will be coming on the side wall, and there will not be any components to counterbalance this particular pressure, and that is why the side wall should be stable enough to handle this kind of pressure difference during the full uh, level of the tank and during the empty situation of the tank. So in both the cases, the uh, pressure distribution in the wall would be absolutely different. Fine. The position of groundwater table is also considered while designing these reservoirs, because that has a lot of influences in the overall stability of the soil, and as well as the chances of contamination will be more depending upon the position of the groundwater table, and that is why it is actually understood and detected before the construction work starts. Now, the floor of these reservoirs may be constructed with RCC slabs or square stone blocks resting on columns. Now, to obtain water tightness, bitumen compounds are used to all construction joints. Otherwise, there will be a chance of leakage, and which will result in contamination of the clean water, which are expected to be delivered. At the top of the roof, about 60 centimeter thick earth layer is deposited and maintained green lawns to protect the reservoir from cold and heat, because you are going to store clean water over there. And for aeration of water and inspection, ventilation pipes and stairs are provided respectively, which can be seen in the figure. So you can see that ventilator is there. Fine. So in order to have proper air air circulation within the tank, and then for if the tank is huge, in that case we need to provide the stairs in order to maintain the tanks during when it is empty. Now let us try to talk about a bit more on the you know different material which are used. So RCC tanks I have already mentioned in the beginning while talking about overhead tanks. So RCC tanks are very popular because of its inherent advantages, which I have already mentioned. Next comes galvanized iron tanks, in short GI tanks. So GI tanks are generally in rectangular or square in shape, and these days GI tanks are not preferred because of some demerits. So life of the tank is short because there is a chance of corrosion of the metal. Obviously that's a problem, and maintenance cost might be very high if you want to avoid the corrosion, because you need to maintain it, you need to paint it maybe every year. So that is why GI tanks are not prepared these days. So in our country, the philosophy is, since we have we have I would say deficit in competent manpower. That is the reason we don't prefer kind of structures which needs more maintenance. So that is the reason RCC tanks are preferred these days. Apart from that, we have HDPE tanks also. So HDPE tanks are very popular for storing less quantity of water and hence useful in residential purposes, very well. And there are several advantages of utilizing HDPE tanks. So basically, if you see, HDPE tanks are easy to handle since they are lightweight. At the same time, this is very cheap in cost. Maintenance cost is absolutely low, and cleaning of these tanks are easy. So that is the reason HDPE tanks are these days used. But in longer period, whether there are some effect of this, since this is a synthetic material and water is stored all the time in such kind of tanks, what is the long-term impact of that water after consumption is still a matter of dispute, I would say. And we need to understand this fact, because see, we are actually, when we are installing a tanks, HDPE tanks, so this is a synthetic material. So that is the reason we have to understand its long-term effect as well. Now with this, I'll talk about some general requirements for domestic water storage. So to store the treated water till it is distributed to the city, In case of domestic, in case of residential, to store water during the non service, or maybe when water is not distributed, so non distribution period. So in case of intermittent supply, to absorb the hourly variation in the water demand and thus allowing the treatment units and pumps to work at the average constant rate. This will reduce operation and maintenance cost of the treatment as well as improve their efficacy. Now, this is a very important points which we should be remembering, or points to be pondered. The second point, is really, really important. So that's the main purpose of actually of domestic water storage. You have certain capacity of your treatment plants, you have certain capacity of your pipe mains, but then if you need for a particular period of time, if you need higher demand and if you need more discharge to satisfy that, so what is done is, in order to avoid that, simply storage has been facilitated and you just store that clean water, and once this demand is higher, it doesn't affect much to the rate of discharge through which water is coming and getting the storage filled. So that is why storage are domestic water storages are provided. Fine. Now, for meeting the water demands during fires, so that is another one thing. In case of fires, what happens is, for a small time period, we need huge amount of water. So the demand increases for a shorter period of time, and to meet that demand, we need to store the water somewhere. And if we have water storage facility, then that would actually help in fighting the fire. Next is, in case of breakdown of pumps, repair the storage reservoir will provide water. So during the non-serviceable period, I would say you get uninterrupted service of the water, because see, once water line is water is being supplied, you are getting directly, but at the same time water is getting filled up within the storage facility. And once your supply time is over, or supply period is over, or if there is a maintenance requirement in the same distribution network, in that case, during the time of non-serviceable hours, you can get the water from the domestic water storage. So these are the different requirements of domestic water storage which I wanted to discuss, and with this we'll actually finish this particular module and we'll move to the next module. If you have any question, you can ask me, or otherwise I'll move to the next module. So once we have finished the distribution network and distribution system, now we should be talking about plumbing system and wastewater. So wastewater is the second part, and maybe I'll not start that. Better I'll talk about only plumbing system.
So how do we measure the storage capacity?
How do you measure the storage capacity? I did not get your question.
Sir, of any particular tank, sir. What is the what is the storage
So when you
capacity of the
construct a
tank?
tank, when you construct the tank, you first design it. You first design its volume. Accordingly, you design how much load is going to be carried by the structure, and then you construct it. So once you construct it, after that you are not going to know the volume. Fine. First, you know the volume, what is required based on the design population, and accordingly you construct it. First, try to understand the chain. And if you are talking about HDP reservoir, so you go to the market. The manufacturer has already mentioned that you want to take a 1,000-liter tank or 2,000-liter tank or 500-liter tanks, and accordingly you get it. So always your demand and accordingly how much storage is required is fixed beforehand, and accordingly you are planning things. So here there is no provision of knowing it after installation or after construction. Is that clear?
Okay, sir.
Okay, fine. So now we'll be talking about plumbing system. So the next immediate part, you all know that So in water supply plumbing system, it consists of few very important components, and we need to know all these terms relating to plumbing, their principles and the common practices of and using this particular. So plumbing is generally a term which indicates the practice, materials and fixtures used in the installation or maintenance of all pipings, fixtures, appliances and other appurtenances used in connection with both public and private water supply systems, as well as sanitary or drainage systems, uh, within or adjacent to any buildings or its connection with any point of public disposal. So that is what is known as plumbing. So plumbing, itself is a holistic term, and it consists of so many different aspects of the you know distribution network, pipelines, etc. Fine. So plumbing water supply system is a different component. Plumbing wastewater or drainage system is a different component. So now we'll be discussing, keeping in mind about the water supply system. Fine. And we have different types. Now let me show you if I have a figure. Okay, I'll come to that later on. Now let me first, define different components which we have been using or will be using in future. The first one is water main. So a water supply pipe waste in administrative authority for the use of public or community is known as water main. Fine. So the main supply line is the water main. Next is ferrule. So ferrule, it's basically is a right angle sleeve made of brass or gunmetal and is joined to the hole drilled in the water main, to which it is screwed down with a plug. Its size usually varies from 10 to 50 mm dia, and for all other connections or more than 50 mm dia, a T branch connection is required. And you know, ferrule, the pressure in the domestic supply and equal distribution among the house are actually adjusted through the ferrule opening. So ferrule is a very important component in the distribution system. Next comes saddle. So saddle, it is used in place of ferrule for mains of AC or PVC pipe. Fine. So asbestos cement or PVC pipes, we use saddle in place of ferrule. So though their function is quite same, but because of their structural difference or difference in the material, we call ferrule and then saddle. Fine. Next is communication pipes. So it is a pipe taking off from the ferrule for the house connection. So after just try to imagine the entire scenario from the water main, you are actually connecting it through the help of ferrule, and from ferrule to your house, the communication, the pipeline which is actually connecting this route is called as communication pipes. Now it is owned and managed by the water supply authority, which is very important, and communication pipe terminates at the boundary of the consumer's premises. So once it is within the boundary of a private premises or a consumer's premises, then the maintenance and the management of that particular point onwards towards the within the house will be done by the individuals, not by the water supply authority. And that is why communication pipe gets terminated at the boundary premises of the consumer's property. Fine. Next is service pipe. So we'll be talking about service pipe here. It is the part of the house connection beyond the stopcock. Fine. And it is owned and maintained by the consumer. No pumps shall be installed on this pipe. So just try to understand the difference between communication pipes and service pipe. So and next is water meter. So it is installed to measure the flow, and it is an integrating meter that records the total flow up to the time of measurement. So that is why water meter is very important. And this water meter, if you see, it basically records the quantity of water consumed in a particular house, and the domestic type of water meter generally employed for house is fitted into the service pipe with unions which enables the meter to be changed where necessary. Fine. So generally 12.5 mm to 18.75 mm rotary water meters are installed either at the beginning or at the middle of the service pipe. And a masonry pit is constructed around it, and it has facility of sealing by the water supply authority. So if water supply authority see that there is a case of you know theft, or people are illegally taking out water by bypassing the water meter, in those cases they have the authority to seal this. Fine. So usually you have that iron box fitted, or you have this kind of masonry pit which will be constructed. Fine. Next is residual pressure. So it is generally measured at the ferrule and should be at about 7 meter head of the water, as far as the water supply is concerned in our country. And so residual pressure is basically monitored at the point of ferrule, or it is measured by ferrule. Now it is measured at the point where ferrule is actually attached, or ferrule is connected with the water main. Next is gooseneck. So gooseneck is small sized carved pipe made of flexible material, usually lead, and is about 75 centimeter in length. Right? And forming a flexible connection between the water main and the service pipe. So sometimes such kind of components are also necessary to connect, and that is the reason gooseneck is a very important component. Now another one, I guess I missed one, that is the stopcock. So stopcock is provided before the water enters the water meter in the house. Fine. And it is housed in a suitable masonry chamber again, and with a removable cover, and is fixed in the street close to the boundary wall in an accessible position. Sometimes it is provided just before the water meter inside the house, keeping both of them in one chamber. So the idea of the stopcock is, if you want, you can basically close supply of water in a particular premises for some reason. So that flexibility can be obtained from the stopcock. So now we'll be talking about the requirements of plumbing system. So what it does, plumbing system, what are the important so let us try to understand this. The first one, it says, plumbing of water lines should be such as not to permit backflow from cistern and sinks. Fine. So this part is very important. We have to do pumping in such a way that there is no backflow from the cistern or sinks, because that will contaminate the water. So we'll have to ensure, or we'll have to make sure this part. All joints shall be preferably watertight, and no leakage or spill at taps or cocks should be allowed. So this part is very, very important, because if you have so many different connection or joints within your house or residential building, then it will mess the entire area. That's the one thing. Another one thing could be the wastage of water, and if it happens in main pipes, or in the connection where main pipes and your service pipes are connected to each other, then the loss of water will be huge, and that will actually affect the overall cost of the scheme. So that is the reason we have to ensure that all joints are perfectly watertight, and there is no provision of leakage or spilling of water through the taps and other appurtenances. Number 3, pipelines should not be carried under walls or foundations. So this is another one very important part. So safety from both the different structures are required to be considered here. So if you are actually laying a pipelines beneath the footing or foundation, so you are creating a disturbance for that foundation, which can create cracks or differential settlement in the overall superstructures, and at the long run it can damage the pipe, or there might be breakage of the pipe because of the extra stress which is coming on that. So that is the reason it is always avoided. It should not be close to the sewers or wastewater drains. So this is another one very important aspect. Always water supply lines are separated with more tolerable space uh, with the sewer lines. The reason is, if you make them close, or if you construct them close to each other, there is a high chance of contamination, and there should not be any possibility of cross connections for that matter. Next is, when pipelines are close to electric cables, proper precautions for insulation should be observed. Why? Because electric current can um, pass through the water, and that can be very dangerous and often life-threatening. And in order to avoid such kind of things, uh, you know, proper insulation should be maintained. If you have a situation where you need to construct a pipelines close to electric cables, so proper insulation has to be ensured before you go ahead. Next is, plumbing lines should be such as to afford easy inspection and repair of fixtures and joints. So this is another one important part, and here a lot of experience and planning is required, so that you do a best possible plumbing lines where the inspection and repairing work is very flexible and you can do it anytime. Next is, the number of joints should be less and the number of bends and teeth should be less, because that would affect the overall pressure. Like, there will be more head loss if you have more joints and as well as more bends. So that is why you plan accordingly, and then create a schematic diagram and choose among different schematic diagrams which one is the best and which one have the least number of joints and as well as bends or teeth. Number 8, it should apply adequate discharge at fixtures, uh, economical in terms of material and protected against corrosion. Air log, negative pressure and noise due to flow in pipes and in flushing should be minimal, because see, these are the hazard of operation and should be considered in order to reduce all sorts of losses. And so that is the reason we should have adequate discharge in all the fixtures in order to avoid such things. Next is, we are going to talk about the different type of connections. So basically, you will be able to see different components which I was talking about. So gooseneck is there, ferrule is there, and you can imagine that we have road surface, we have stopcocks, and then we have the so this portion is basically the boundary wall. You can imagine this is the boundary wall, and this is the bottom part of the boundary wall, which is actually within the ground, and this is an imaginary line which is separating both the premises. So this is the property boundary of the consumers, and we have that water meter here, and you have the stopcock over here, and often they are attached close to each other and create a common housing for both of them. And this is the communication pipe, this is the service pipe. Now we'll try to understand in best possible way. This figure is much better than the previous one. So you can see here we have the ferrule connection, and then we have wipe joints, and then we have service pipes, and then we have domestic water meter, and then water supply to the building. And this is the boundary wall or foundation of the boundary wall which we are talking about. Now, in case of where we have gooseneck which is required to provide, so sometimes in water main, if you see, so here we are actually seeing the cross section, and here we are seeing the plan. So in the plan view, you see this is the main line through which it is coming, and then we have a gooseneck pipe, and then it goes to the stopcock, and from stopcock it goes to the water meter, and then in the residential area. And the components which are actually mentioned over here, I have described and explained them before, so that it will be good for you people to understand better. Fine. Now I'll move to the next part. So yeah, so stopcock is the next one which we are going to talk about here. So this stopcock is a screw down type of sluice valve. There are similarity with the sluice valve which we discussed or explained in, I guess, last to last class. And this is a kind of a sluice valve which is used in smaller sized pipes in service connections for stopping or opening the supply. So the main idea of this is, as I mentioned, that to create more flexibility in the supply. So if you want to stop for some time in particular premises, then you can operate this stopcock from outside. So they are generally provided at water entrance of each building and also within the building itself if it is required. When provided just prior to the water meter in each house connection, they should be enclosed in proper cast iron box and having a hinged cover, because they are expensive compared to pipelines, because this is a appurtenances, and that is the reason we need to have proper house to maintain them and to cover them from any physical damage. And we have shown here a typical stopcock schematic diagram. The body of the valve is so cast that the water passes through an orifice within the valve stem when it is raised up. When the valve is closed, the rests against the seat and thereby closing the orifice, and they are extensively used in pipes up to 50 mm in sizes. Fine. So from the you can see that there is a valve and you have the handle, so the threaded handle, and the valve is connected to the stem. And if you operate the handle, then the valve will go up and come down, and once it come down and rests on the seat, then there will be no provision of water to pass. But once you raise the handle, so the valve will go up, it will get detached with the seat, and then the water will pass and it will go within the water meter. Fine. And mostly they are extensively used in case of pipelines up to size 50 mm. So this is the way we basically utilize stopcock in creating more flexibility in the main water supply system. Next is water taps or bibcocks. Now this is another one important part, and many of you or most of you have seen these bibcocks at your toilet, washrooms, as well as in kitchen. So these water taps are these water bibcocks are also known as water taps, and water taps are the type of valves provided at the end of service pipes for withdrawing water at the consumers' houses. Now, several varieties of water taps are available, and most common of them is a bibcock. And in the right hand side bottom, I have shown a schematic diagram of bibcock, and the working principle is more or less similar to that Swiss valve which we discussed, and stopcocks also here. So you have the handle, and then that is the valve, main valve body is attached to the handle by the stem, and you have an opening through the orifice. Now what happens is, if you put down the valve by rotating the handle, then what will happen, there will be no provision by which water can pass through. However, if you are putting the handle, you are rotating the handle in other direction, so it will go up and it will make the orifice open, and through that opening of the orifice, water will pass and it will come through the spout. Fine. And we can actually control the flow through the spout by adjusting the handle. All of you have done that, but now we are actually seeing the schematic diagram and how it works. Now they are available to be fitted in different pipe size from 10 to 50 mm dia. All of you know that for different type of pipe size we have different type of bibcocks available, and there are few important points which should be kept in mind, that bibcock may also be push type, or they can be operated automatic by the help of some sensors. These days you can see in the washroom also. Now they should be absolutely watertight, otherwise the wastewater quantity will increase from the washroom. The leaky bibcocks are the source of wastewater, as I mentioned. So that is the reason always you should ensure that the bibcocks which you are attaching in the end of your service pipe is absolutely free from any leakage. and to ensure that the rubber and leather washers are used, and to proof it from any sort of leakage. And if that is damaged because of several uses, then again we change those washers of rubber or leather, and then we can ensure that uh, water tightness for the entire service life of the deep cocks. So with this, we'll stop today.